The UVLM.OpenFSI was developed by ZONA under a contract, and the UVLM stands for the Unsteady Vortex Lattice method. So this was a software that was developed by ZONA, and as part of the output from this software, it can output the aerodynamic model and the vortices that are shed downstream from the, for example, the tip vortex and the trailing edge wake vortex. So what ZONA-MV allows you to do is load the plot file that's generated from that software and to display the animated vorticities as they're shed downstream. So we can use the import option UVLM.OpenFSI file, which brings up this dialog. Then we go select the file that we want to load, and these files tend to be rather large because they are output over many time steps. So in this particular case, this file is somewhere on the order of 700 megs. So we have an option here. So there's okay, on the left hand side, mirror data on load. So if we happen to have a half model and we want to mirror the data onto the other side, we could select XZ plane. In this case, we have a full span model, so we don't need to mirror the data. Limit data to load. The purpose of this is to be able to specify a starting time step and an ending time step. So if we went from time steps, say for example 0 to 500, and we only want to plot the first 200 time steps, we don't need to process the entire file. So we can tell the program here that we want to go from 0 to 200. If we don't know the time steps within the file, we have this Get File Info button that we can click, and then it will process the file and give us the information back for this particular UVLM.OpenFSI file. Now if we leave from time step and to time step as 0, then it will load all of the time steps within that particular file. So now it comes up and it says that the number of zones, we have 47,100 zones. The number of variables are 4, which will be the XYZ coordinate of all the points for both the model and the flow field, as well as the CP values. The number of lines, which we have here about 8.8 million lines in the file, and the number of time steps are 300. So we say OK, it will auto-populate the fields from the first to the last time step, and if we want to load all the time steps, we just click Load Data. So once the data is loaded, we see the model here, and in the message output it gives us feedback about the file information that was loaded. For example, the total number of time steps, the arrow mesh lines is 300, the number of zones 47,100, number of variables 4, and the total number of lines in the file. The variables that were loaded, XYZ and CP for the surface of the aircraft, the CP, and the so it gives a zone reduction for the trailing wake and the corner wake to reduce the number of zones. So when we go to the zone settings tab here, then we can bring up and take a look at what's output from UVLM. So for 300 time steps, we have 3 zones that are repeated over and over. The first one is the aerodynamic mesh, which is this black mesh of the model here. The trailing edge wake, which is shown in blue here. And the corner wake, which is shown in red here. So if we want to animate this, we need to animate through the 300 steps, skipping every 3. So we've added some additional options in the animation for zones. If you go to the Tools menu option, the Zones button, it'll pop up a dialog, and it'll show you here that you can. It's starting at zone number 1 and ending at 900 because there's 3 zones per time step. So what we want to do is skip steps every 3, and then the number of zones to display per step, we want to make that 3, so it'll display 3. So if we do this now, right at this point, we start the animation, then we can see that it'll animate. And what's happening here is that the aircraft is hit by a gust in flight and then responds to that gust, and we can observe the trailing edge wake and the corner wake, or the tip vortices, that are shed from the control surfaces here, the horizontal T-tail, and from the fuselage and the trailing edge of the wings. So if we want to slow that animation down, we just simply put in a delay here, for example 25 milliseconds. We can start the animation and slow it down that way. Now there's some tricks we can do that if we want to observe the wake in terms of, let's say, particles rather than elements, the way we see it here. I'll stop the animation, close the dialog. I'll rotate the aircraft to look from the front, and then I'll select the dynamic rotation tool. I'll tilt the aircraft down a little bit, and I'll zoom in. And we can turn on the contour because we in the UVLM file we also have the CP on the vehicle, so if we want to see that as well, we can do that. We'll click on contour, and it'll pop up the CP values here on the fuselage. And so what we're going to do is, if we want to look in terms of particles for the wake, we can go back to the zone settings, and we want to turn off the shading for the wake, as well as the elements, and turn on the nodes. So if we turn on the nodes here, we'll see the nodes on all three zones displayed. Then we can go to the zone settings, and we're going to turn off the elements and shading for the trailing wake and the corner wake. So to do this, rather than select all of these zones individually, we have an option in here to make that a little faster. You can click on this zone name button, and it'll pop up with select by name. If we click on that, we can put in the name of the zones that we want to select, and we can use wildcards to select multiple. So for example, trailing wake, we can just simply use TR star, which will select everything that begins with TR. We say OK, and it'll highlight all of them in here. Then we can say that show elements no, because we want to turn the elements off, and we can go to the shading and turn the shading off as well. Then we can do the same thing for the corner wake. So we come over here, we select by name, we say CO star, say OK. It'll select all the corner wakes. We're going to say shade show no, and we're going to go to the elements tab, and we're going to say show elements no. Okay, so this way we're just looking at nodes for the wake and the corner wake, the trailing wake and the corner wake. Now we also want to turn off the nodes on the fuselage here. So the way we can do that is on the arrow mesh. We go to the nodes tab, then we click select by name. We're going to say AE star, and it'll select all the arrow mesh zone entries. And then we can go to show nodes and say no, and it'll turn off the nodes here on the aircraft. So if this, so now we can close the zone settings window and go back to the animation for the zones, and we're going to do the same thing here. We're going to step 3, show 3 zones per time step, and we'll slow it down a little bit more with 50 millisecond time delay, and then we'll click start animation. And now we can see when the aircraft is hit with the gust of air, we can see the response and then see the pressure change. It's kind of hard to see right now from this angle on the control surfaces, and then the wake that's shed downstream from the trailing edge of the wing and the control surfaces and the T-tail. So once this finishes, if we want to clearly see the corner wake, and we can actually turn off the trailing edge wake, we go back to the zone settings. Again, I'll select by name TR star to select all the trailing wake, and we'll go to zone show and deactivate the zones. So now all we're seeing are the corner wake vortices. And then we can animate this one. And let's say we want to look at the left wingtip, maybe make it a little more interesting. I'll go ahead and I'll zoom in to this region here. Go back to rotate. That was a little bit too much of a zoom. Okay, so we can get a better view out at the wingtip. We can also zoom in on the contour, the CP values. So let's say we take this down, exaggerate it from -1 to 1, and increase it to 31 steps. And now we can more clearly see the pressure changes on the control surface. And then we'll go ahead and animate from here. So we go back to the zones, and we select 3, skip every third step and include 3 zones in every step of display. Reduce the speed by 50 milliseconds, and then we'll start the animation. So now we're just looking at the corner wake that emanates from the wingtip and the edges of the control surfaces here. So the aircraft is hit again by the same gust, and the wing responds, as do the control surfaces, so we can see the CP and the particles of the vortices from the corner wake that are shed downstream. So in this fashion, then, we can use ZONA-MV to post-process results that are output from ZONA's Unsteady Vortex Lattice method called UVLM.OpenFSI.